Natural resources, and first of all oil, is the source of Russia's wealth. Although the fact that oil fields are situated far from industrial areas and oil refineries pose a serious problem. That is why thousands of kilometers of steel pipelines have been built across swamps, forests, riverbeds, and mountain slopes. In this world, nothing is eternal. Pipes are born to live, get old, and perish like everything else. Yet their sickness may turn into an ecological disaster. That is why constant monitoring of all oil pipeline systems of Russia is so important. A scientific approach based on the most up-to-date international achievements in the field of development and maintenance of in-tube diagnostic devices, full-time complex in-tube control and monitoring has led to the creation of the Diascan Center for Technical Diagnostics. Prior to diagnostics, the pipeline should be cleaned and its cross-section should be measured. To this end, the scraper is put inside the pipeline. It cleans the pipe completely from accumulated sedimentation so that the gear that will follow the scraper would provide exact coordinates and parameters of possible defects of the pipeline. The profile measurement machine is the first diagnostic gear to be put into the pipe. It makes a good speed inside the pipeline and can even pass sections of the pipeline with cross-section reduced to 70% of the nominal value. It detects changes in the cross-section of the pipeline and locates its position on land. The multi-channel feature is one of the important advantages of the new generation of profile measurement machines. It is provided by lever sensors attached all around the gear's body. The profile measurement machine provides data for interpretation of dents, corrugations, cross-section ovals, weld seams, padded rings. To avoid loss of recorded diagnostic information, company specialists use very reliable electronic data storage devices, special flash disks with no mechanical parts. In order to locate detected defects, profile measurement machines are equipped with mileage calculation systems and angular position detection devices. Navigation equipment, also installed on the gear, helps to get accurate data on the pipeline's position on land. WM high-resolution ultrasonic defectoscope follows the profile measurement machine into the pipeline. Its sensors are facing the pipe surface perpendicularly and measure pipe wall thickness, detect corrosion, mechanical damages such as grooves and exfoliations, flaws of metallurgy production. CD ultrasonic defectoscopes with angle-fire ultrasonic radiation detect the most dangerous defects: cracks in longitudinal weld seam and longitudinal cracks along the pipe's body, grooves, and scratches. Waves travel inside the pipe with an angle of 45 degrees to its surface. Sensors record information every 3 millimeters of the distance. Depending on the difference between time that the wave travels from the pipe's surface and the time it travels from the crack's bottom, the crack's position can be detected, whether it is on the inside or on the outside of the pipe's body. Data analysis team specialists use software to analyze initial data recorded by the gear, interpret defects, sort them into different types, and measure their geometrical parameters. Diascan uses different modifications of CD defectoscope center carriers to either detect longitudinal crack-like defects or to detect defects in longitudinal and spiral weld seams. The next gear is magnetic defectoscope. Unlike the ultrasonic method, it does not directly measure defects. Defects are revealed through the changes in magnetic field created by permanent magnets. To transmit magnetic flux to the pipe surface, magnets are topped with brushes made of steel wire which slide along the pipe's inner surface. The magnetic flux created inside the pipe's body flows along an axis of the pipe. Between the rings of brushes, there's a ring with a spring-loaded sensor block holders. Gear-borne equipment registers changes in stray field's density. When a defect comes into the magnetization zone, the magnetic field is distorted and it is registered by sensors. An additional ring of detectors in the tail unit of the defectoscope locates the defect, tells whether it's on the inside or on the outside of the pipe's wall. When interpreted by original software developed by Diascan specialists, these records turn on the monitoring screens into defects, metal losses, anomalies of weld seams, cracks in longitudinal weld seams, unions, patches, casings, and various tubular goods are also registered. All data received through scanning of the pipeline by in-tube diagnostic devices is interpreted and provided to the customer. But each of the above-mentioned diagnostic devices that utilizes only one physical, non-destructive method of testing provides spotty information on the pipeline's defects. Complex diagnostics is provided only due to the utilization of all types of in-tube defectoscopes. That is why Diascan created a unique combined defectoscope, the gear which is not produced anywhere outside of Russia. Its operation is based on different principles of non-destructive inspection technique to gather maximum information on pipeline defects in a single run of defectoscope through the pipe. The gear is the product of integration of the best international technical, scientific, and engineering achievements in the field of in-tube diagnostics. The ultrasonic module that consists of sensors with direct and angular beam input detects corrosion and even smallest crack-like defects 1 millimeter deep. It means that the device reveals the pipe thickness at the earliest stage. All electronic equipment of the ultrasonic module is most up-to-date and forms a unique, compact, and highly efficient unit combining functions of two different defectoscopes, WM and CB types. The magnetic module of the combined defectoscope is built like a usual magnetic defectoscope. However, it has a composite block of magnetic sensors that detect defects themselves, as well as their inner and outer location. It helped to reduce the size of the module and defectoscope in whole. The creation of this unique combined defectoscope gave Diascan specialists a powerful tool that reduced cost and time necessary to check Russian oil trunk pipelines, improve quality of information on the pipe's defects. The result is a most accurate assessment of the oil pipeline's invisible existence. In one run, the combined defectoscope completes the full diagnostic cycle of a single section of the pipeline. One device does the same amount of work that used to be done by 3 different types of gear. Yet the combined device is greater than a mere sum of 3 parts. Thanks to the combination of magnetic and ultrasonic scanning methods and interpretation of the gathered information by software developed using modern methods of mathematical simulation and neural net technologies, the size of defects is detected more accurately. Results of pipelines' reliability and durability estimates make it possible to calculate the pipeline service lifetime more accurately, to choose adequate repair methods, and to reduce repair costs and risks of failure. The number of defectoscope runs is also reduced. What is most important is that all electronic units, all software, all diagnostic equipment is designed, developed, and created by scientists, engineers, and constructors of Diascan. Automatic adjustment of sensors is one more important feature of these modern devices. It makes the operator's subjective error impossible and saves a lot of time. Inbuilt testing and control system of electronic units is at work there. It minimizes the chance of failure and speeds up the launch processing. The quality of defect detection is also high. Technical Diagnostic Center specialists developed original software that enables to detect and sort defects into different types. Combined Defectoscope's data interpretation computer program is Diascan's pride and joy. It interprets the same defect by 3 different methods that determine its location, nature, depth, size, and length. It increased reliability of diagnostic information and reduced maintenance costs thanks to reduced number of defectoscope runs. Unique information on all types of Russia's oil tank pipeline defects have been gathered during the years of Diascan's existence. Now specialists have a unique opportunity to compare results of past and new inspections, to analyze pipeline's condition, calculate the time necessary for repairs, and to determine oil transit regimes. Diascan Technical Diagnostic Center. Everything here is provided for 24-hour operation of defectoscopes. Polyurethane cups and discs are worn out first in the course of maintenance. Diascan produces spare parts itself. It results in no idle time and hundreds of kilometers of inspected pipelines. Any metal part necessary to build new or repair an in-tube defectoscope is manufactured here at the Technical Diagnostic Center. A coordinate measuring machine is used to control precision of manufacturing of spare parts. Micron-level precision of measuring excludes any possibility of poor quality parts being used for assembling of defectoscopes. Extreme conditions of diagnostic gear operation explain the necessity of high reliability of every unit, every electronic module, every component, and every joint. That is why Diascan has developed and practices a complex system of tests for electronic devices, which parameters are thoroughly and meticulously checked. Diascan Technical Diagnostic Center. It creates not only equipment that determines the technical condition of the pipelines. Here the pipeline's service lifetime is calculated. A special hydraulic test bench tests a full-size pipe and maintains defects with real operational load, cyclic inner pressure, and bending. Samples are tested in laboratories, pipes, metal, and weld seams. Technical parameters are identified. Extension, compression, cyclic fracture strength, and impact bending tests are being run. It helps to develop methods of identification of reliability and durability of pipelines and estimates utmost operational lifespan and maximum oil transit pressure. The testing area created here has no analog around the world and has become the experimental base to test all equipment systems and means of in-tube diagnostics. Pipelines have more than 5,000 different defects with already determined geometrical parameters. Test runs of diagnostic devices around the testing area reveal the gear's real detection and measurement capacity of all types of defects in operational pipelines. These model pipelines are necessary to practice methods of defect interpretation, to build in-tube defectoscopes, and to test their detection precision. Diascan Technical Diagnostic Center engineers created new highly efficient domestic diagnostic gear that ensures stable operation of Russia's oil arteries, their reliability and ecological safety.